Hello, welcome to another vintage APL coding video. My name is Jamie. In this episode, I'm going to be coding the game called Bagles, which is a number logic game that's found in the book 101 Basic Computer Games. This book is from the Digital Equipment Corporation, the third printing from 1975. This book can be found on the Internet Archive, and I'll include a link in the description below. I'll be coding this game in IBM APL version 1.00 for the IBM PC. This version of APL came out in 1983 and was meant to run on the IBM PC generation of the time that had a coprocessor installed. And so I'm running this from the excellent website PCJS Machines. There are a bunch of emulated IBM PC instances on this website running lots of old vintage IBM software and IBM compatible software. So this is, again, IBM APL version 1.00 for the PC. There is a link to the documentation, and you can download that. This is of the same generation as APL with shared variables that IBM was producing for the IBM mainframe at the time. And so it includes the shared variable facility. It includes some print formatting facility that we'll be taking advantage of. It includes files, being able to read and write files to the file system, which we will not need for this game, but is also useful. So if you download the manual, you'll see that it's a full PDF version of the manual, and it'll explain how some of these features are used and accessed. There are separate utilities that we run along with the APL executable to load in some of these various features. So these are called AP80 for printer control. That's specifically graphics printing on a line printer of some sort. We'll be using something called EXAPL, which is not listed here, but we will need that for the screen printing, screen print formatting specifically that we'll be using. So this includes documentation of just those specific facilities to IBM APL for the PC, and then the kind of the basics of the language at the time. So you'll see there are there'll be extra system functions, shared variables, and so on that will be specific to this version. Okay, so with that, I'm going to zoom in, and we'll get ready to run APL. We're going to run it here from the floppy drive. The DOS disk is the A drive. The APL disk here is the B drive. You can save once you've saved your workspace. You can actually save the DOS disk image, and you can download it, and then later when you go back to this emulator, you can load the image that you've saved from your local machine and load it into the emulator, and then load the workspace that you've been working on. So that's kind of a neat feature. Even though we are running in a completely emulated environment here in a web browser, you can save those disk images and load them back in. So to get started, we'll run APL, and again, I'll need EXAPL, which the documentation will explain is needed to be able to use the print formatting that we'll use in a couple places. Okay, so this will go ahead and get started, and we're here at a clear workspace. Again, you'll see at the top, we're running version 1.00, copyright IBM 1983, produced by the IBM Madrid Scientific Center. I'll go ahead and move forward so that we can look at the source code for this game. So as I mentioned, this is kind of a mastermind game where the computer will display the computer will generate a 3-digit random number, and then the user is going to guess that number, and then based on how many digits are correct and in the right spot, there will be some clues that are given so that the player can make a better guess the next time. So I'll be using this as a kind of a rough guide. We'll be using some APL features that will let us simplify the basic code quite a bit. So it won't be necessarily line for line, but I'll try to stick to it as much as I can. Okay, so we're going to start by defining the game Bagles, and I'm going to put in my variables up here as temporary variables. So I've gone through the program and I've written these out. We have A, B, C, D. There is an $a variable. I'll call that AD. I, Y. And then there are some variables that I'm going to introduce basically as constants that I'll refer to pico, Fermi, and nums. Okay, we'll see the rules in a minute as I'm typing them in. I won't take time at the beginning just to explain everything about the game, but as we type in the rules, you'll see how this will work. Okay, so there are comments at the top, and then they set up some array variables, which we don't need to initialize here. On line 40 is randomize. In this version of APL, we can set a system variable called the random link. But I don't know of a way to have it set to a random seed. We could set it to a specific random number, or a specific number that will seed the random number generator at the beginning of our program. But every time we would run the program and it would get that seed, it would just give us the same sequence of numbers to guess over and over again. It'll still do that based on the initial seed that's given to the random number generator. If there was some way that we could set the random link variable to maybe the current time in seconds, and we could certainly write code that would do that. We could access the variable that would give us the current date and time down to milliseconds, and then we could use that to compute some random seed so that our program would be guaranteed to give random numbers each and every time. But I'm not going to take time to write that for this simple program. I'm going to start by initializing this variable y to 0. That'll be a counter that when the player has won, it'll keep track of how many times that they've won the game, and then when they're done playing, it'll give them a little bit of a kudo based on how many times that they've won during that session. I'm going to set the variable nums here to be the digits, and I'll use this to check the user's input to make sure that they're inputting valid numbers and not other characters. And then we're going to print out pico and Fermi to give them clues about how many digits they have correct and if they're in the correct position or not. So to aid my printing of those, I'm going to set pico here to be a constant and Fermi to be a constant. And we'll see how those are used in a minute. And now we get to line 70. We ask them if they would like to see the rules or not. So I'll just print out the message here, game of Bagles. Would you like the rules? Y or N? I'll simplify that just a bit. And then we'll get their input with our $a variable. AD gets quote quad. So in one difference, if you've watched my other videos with APL 360, one difference with this version is we don't compose characters, so the keyboard is a little bit different. We have extra keys. For example, there is a specific key for a quote quad, and we don't need to compose that character out of the quad and the quote together. Um, and then there are other keys. Most of them, I believe, are up on the number row that we can access using the Alt key. And so we can get some of those other composed characters using the Alt key. And so that keyboard is in the manual. You'll want to take a look at that. And we don't need to do a line feed when we need to backspace to make a correction. So that can save a lot of time just because we can just backspace and make corrections. For me, it's a little bit harder to use the keyboard in remembering that I need to type in APL characters with the APL layout because the font looks, just like my normal PC font. And so I get in the mindset of treating my keyboard as a normal PC keyboard. Whereas in APL 360, I don't as much because the APL font there is in italics. Okay, so we get the input, then we're going to jump to line 150 if the answer is no. Well, line 150 just initializes a for loop. So line 160 is actually the line that generates the random number. And so that's the line that I'm going to jump to here. So we'll use the branch, which is the right arrow, L160. I'll use that as a label. And so jump to L160. This is conditional. So if they type in that they don't want the instruction. So we code if with the time symbol and iota, and then our condition will be if AD is equal to the character N. Okay, so now we're in the set of code if they do want to see the instructions. So we'll print a blank line, and then we'll print the first line. I am thinking of a 3-digit number. Try to guess my number, and I will give you clues as follows. So the first clue is pico, which is means one digit is correct but in the wrong position. And for each digit that they have correct but that's in the wrong position, they'll see pico. So they could see pico up to 3 times. The next one is Fermi. And this means one digit correct but in the wrong position. No, but in the right position. So they could see Fermi twice. They could have 2 digits in the right position. If all the digits are in the right position, we wouldn't show Fermi because we would just jump to the line that tells them they got the answer correct. So they can see Fermi up to 2 times. And then if they don't have any digits correct, then they see Bagles. No digits correct. Okay, so now we're at line 150. I'm going to skip that. We could have just put in a label for line 150 as a blank instruction if we wanted to, but I'll just skip over that. Our line 160 then, with our label here, we're going to generate 3 digits, and we'll put those in A. Now, to simplify this a little bit, I'm going to just use the digits 1 through 9 and not include 0. Just makes the code a little bit shorter. Because when we generate a random number using roll, which is the question mark, it generates a number from 1 to 9. If we wanted to include 0, we would need to generate a digit from 1 to 10 and then subtract 1 from it. So it's certainly doable. I'm just choosing not to do that. Just simplify the implementation. And the game, to me, is just as fun with 1 through 9. A little bit easier. Okay, so that puts our 3-digit number as an array, and I see I had a semicolon there. Okay, so we have an array with the 3 numbers in it at this point. And for the purposes of the game, if we look here at the code, so they're generating the 3 digits here with this loop I, and then with the loop J, they're checking to see if any of those digits are repeated for their purposes, and it'll be explained later to the user if they try to guess a number that has two digits the same. They'll be told that the digits are all different. So that's what we want to check. We're going to re-roll if any of the digits are equal to each other. So we don't need to do that in a for loop, but we'll just jump back to L160 if, and then our condition needs to check to see if any 2 of the digits are the same. So we will look at if A1 is equal to A2, or A2 is equal to A3, or A3 is equal to A1. Okay, so that'll handle that. Whenever we move past this, we're guaranteed to have 3 digits that are all different. And now we get down to line 210. We're going to print a blank line and then print, okay, I have a number in mind. And then on line 220, they start a loop to allow 20 guesses. So again, we don't have a for primitive. In this case, we will try to do things with using arrays where we don't have to loop, but when we are just trying to keep track of how many times they've guessed, we will need a counter and we'll need to loop back for that. So I'm going to set I is equal to 1. Now, something we may want to do here just for debugging purposes is just to go ahead and print out the number A so that whenever we're testing our program to make sure we haven't made any mistakes, that we can see it later. Then we could go back and remove this line when we're ready to play the game for real. So I'm going to put in an A here just to display the 3 digits at this point. And then we'll set I is equal to 1. So this is our first time through. And then we will jump back to, at the bottom of this section of guessing, we're going to jump back to line 230. So that's where we'll print their current guess number. So I'm going to give this line a label, L230. Print guess. Now we don't have the number sign available, so I'm going to use a colon and a space. And then we can use a comma. And then I'm going to use the format symbol here to give us the number. It'll convert the number I into a character so it can be displayed here along with this character array. Okay, so this is one of the new symbols, one of the new commands that we can use that's not in APL 360. In APL 360, we can separate the numbers from the characters with semicolons. We'll see later we can get a little bit more uh, formatting where we can put numbers with, we can have extra digits and decimal places and so on, although we won't need it for this game, but that is built in with the format character arrays, I guess. We could call those, I'm going to call them format strings, but we don't have strings in this version of APL. Okay, so print out their current guess number, and then we're going to prompt them. So we're ready to get their guess. On line 240, input $1. In BASIC, they would see a question mark when something needs to be inputted. But in APL, when we get a character from the user as a quote quad input, they won't see anything. So I'm going to go ahead and print out a question mark here, just so they know we're waiting for them to input their guess. And then we'll get that with AD gets quote quad. Now we're going to do some checking, and we'll jump to some other, let's see, we'll jump to some places where we'll give them feedback based on their input. I can't think of a good way to word that. So they need to enter 3 digits. So if they don't, so let's see, we're going to, they do some checking over here if they try to enter in something that's not within the range of the numbers. And so they're using the kind of internal numerical representation of the characters to see if they're numbers or not. Then they'll print what. Then later they get a message down here telling them try guessing a 3-digit number. If they put in 2 digits that are exactly the same, then they get another printout saying, oh, I forgot to tell you that the number I have in mind has no 2 digits the same. And so that's going to be the next part of the code that we're doing here. So let's see, we'll jump to 630. We'll jump to L630 if the length of their input is not equal to 3. So if so we'll use row for the shape or the length of AD is not equal to 3. So that'll prompt them to enter a 3-digit number. Now, next we'll check to see if all 3 digits that they've entered are in our numbers. And so that's where we're going to use that nums array that I initialized at the beginning. And if it's not, we'll jump to this line 300, which will print what. So jump to 300 if, and let's see how we want to write this. So we want to make sure all 3 digits are members of nums. And so if they're not, then we want to do the jump. So I'm going to use a tilde here to mean not. And then in parentheses here, we'll check to see if the first digit is a member. So we'll do the epsilon which is Shift E. If that's not a member of nums, so the internal part is if it is a member, but then we're negating that, and then we'll use and AD2 member nums and AD3 member nums. Okay, and then we close those parentheses, and I think we have enough closing parentheses there. Okay, so at this point, they should have input 3 numbers. The numbers are, there's 3 characters at least, and we've checked to make sure that the characters they've input are numbers. So we're going to go ahead and convert that to a numeric array, and we'll call that B. So if we see over here in the code, they've already set B to be the user's numbers after they've checked to make sure that they were numbers, and then if any of those numbers are equal to each other, then they jump to 650. Let's see, we need to jump to L320, so we're going to go ahead and convert it. So we've done our checking, and then we're going to store the number in B and then jump to 320, and then we'll have to print out, then we have the section for doing the what there on line 300. Okay, so B gets the conversion will be using the execute operator. So this is the circle with the bar underneath that converts a character into a digit, provided it's equivalent to a digit. And so the first position of our array will be from their input, which was AD, and then we'll do the same thing for the second position and then the third position. Okay, so then we're on line 295. We'll jump to L320. Now we're at label 300. Line 300, print what? And then go back to L230. Okay, now this next section is checking to see if any of their numbers are the same. If they are, then they're going to jump to 650. So we're going to jump to L650 if, and then we need to check our 3 digits. Just like we did above for the computer's 3 digits, we're checking the player's 3 digits here. If B1 is equal to B2, or B2 is equal to B3, or if B3 is equal to B1. Okay, so that'll take care of that. And then we set C and D to 0. Variable C will be used to hold the number of digits that are correct but not in the right position, and variable D will hold the number of digits that are correct and in the right position. So we'll do C gets D gets 0. Let's see, this is starting at line 320. where we're checking to see if those digits are in the correct. I think I missed a line here. Let me go back. So I wanted to label right before this checking to represent. We need to in line 295 go to 320. So I'm going to add that between 28 and 29. So I'm going to go 28.5. And I'm just going to put in a label here that represents 320. So I'll do L320 as a label, but I'm not going to put any code on it because the code is already there in line 29. Okay, let me redisplay all of the code. Okay. Now as we get off the screen, if you want to only display certain line numbers, if you want to see a certain section that you don't want scrolled off the screen, we can do it like this. We can do a left bracket 20, the quad character, and then so that's the beginning of the section we want to see, and then the ending number of the section we want to see, and then a close bracket, and then that will be used to display those. Okay, so I'm going to jump out and then jump back in so my numbers will get reordered here. So we'll go back into Bagels and display everything. Okay, so now I have whole numbers again for all of my line numbers. So the next line, we need to set C and D to 0. So that's what I was working on whenever I saw that we'd left out that line. C and D both get 0. Okay, so now there's a bunch of logic that goes through and checks to see how many numbers are in the right are correct but in the wrong position, and then how many numbers are correct and in the right position. And I've been able to simplify this quite a bit using just using our array operators that we have in APL. So I'm going to first of all calculate D. This will be the numbers that are correct and in the right position. So D will get, now how can we do this? We're going to compare A to B. So we get, we'll use A equal to B, and then this will give us an array back, a Boolean array. If the number that we've guessed is in the right position, there will be a 1. If it's not, if the number is, if in the position we're looking at, if the number is not the same, we'll get a 0. So this is specifically looking at numbers that are correct in the right position. So we get that Boolean array. It could be 1, 1, 1. If they're all correct, it could be 1, 0, 1, 0, 1, 1, 0, 0, 0, and so on. So we want to add those together to come up with the total of numbers that are correct in the right position. So we will do that with a plus, get the right key here, with a plus followed by a slash, which will sum up all of the digits in our comparison. So add the digits for A equals B. So plus slash together, we can read that as being the sum of A equals B. Now, to compute C, we're going to check to see if, so let's do this a bit at a time. We'll check to see if if the digits of B are somewhere in A. And so this will count both the places where the digits are in the right spot and where they're not in the right spot. C, though, for us will be the number of times that we're going to print pico, which means a digit is correct but not in the right spot. So we already have D being the digits that are in the right spot and correct. So C is a combination of both. Digits that are in the right spot and correct, and digits that are in the wrong spot but are correct. So we're going to take the sum of this, just like we did previously. So we'll do the sum of A member B. So where B, the number digits that have been guessed, are the digits that the computer has provided, minus, so we want to subtract all of those that are in the correct spot, because we don't want to report those as part of Pico. They will get reported as part of printing out Fermi. Oh, minus D. And I think I need to put this in parentheses. So let's see, should be able to press the insert key on my keyboard, and this will turn into an insert operation. And remember where my parentheses are. I want to put this in parentheses. Okay, like that. Okay, so once we've come up with the correct quantities for C and D, then we get here to line 500. If D is equal to 3, jump to 680. So that's going to tell them you got it, that they've guessed correctly. So jump to L680 if they've guessed the correct digits all in the correct spot, then D will equal 3 at that point. So if D is equal to 3. Next, we will print out using C, we'll print out Pico, the number of times that they've guessed a number that's not in the right spot, and then print out Fermi. So I'm going to use those constants that I created earlier and a method to just get the correct number that I need. So for Pico, in my constant Pico, each one of those is represented by 5 characters, which is Pico, P-I-C-O, plus the space. So I'm going to use C times 5. So C might be 1, 2, might be 0, so none. Could be 1, 2, or 3. So out of that array, take 5 characters at a time, and I'll use the take symbol, which is the up arrow, from Pico. And then, so that'll display the hints for Pico, and then for Fermi, I'll use D, the number of digits in the correct spot, that are correct in the correct spot, times 6, because Fermi plus the space is 6 characters. And I'll take that from the Fermi variable. So then we get to line 580. If C plus D is not equal to 0, then jump to 600. So we're going to jump over the part that prints bagels, if that's the case. So jump to L600 if C plus D is not equal to 0. So now on this line, we will print bagels because we know that C plus D must have been 0. They didn't get any correct. And then we are at line 600, which is printing a blank line. And then we get next I. So this is going to increment I and jump up to the place where they are told they've used another guess. And they've used another guess, and they get to try again. So we need to increment I here. I gets I plus 1. And then we're going to check. We didn't check above to see if they've done all. The game here gives them 20 guesses. So we're going to do that check here. If the number of guesses is less than or equal to 20, we're going to go ahead and do the jump back up to L, that label up here, L230, where they get to do the guess. For testing purposes, we may not want to do 20. I'm going to pick 5. That'll just make it quicker for us to test the case where we've used up all of our guesses and to make sure the program works. And then again, we can go back and change that later here. So jump to L230. So jump back up if I is less than or equal to 5. Okay. Now the next line is if they've used up all their guesses, we're going to print, oh well, that's 20 guesses, and then we tell them the number. So we'll print, oh well, that's, now to include a quote as part of your character array, we use a single quote twice, so that the single quote will actually print as part of this. So that's 20 guesses. My number was, and then we'll use the format operator, and then we want to take that array A, which is the computer's guess, as 3 separate numbers and combine them into one 3-digit number. And so we can use decode in APL. So what they've done is they just multiply the first digit by 100, the second digit by 10, and the third digit they leave alone and add those together to get the number. And that's exactly what decoding with base 10 will do for us. So I'll put this in parentheses, 10 decode A. So that's the computer's guess, and it's going to be displayed. Okay, I think that's sufficient there. And then there is a jump to go to 700. And then we have some of those response messages that we've used, that we've referenced previously. So we were going to put those in here. So we have an L630. Try guessing a 3-digit number. And then jump to L230. And then we have an L650 reference here. Oh, I forgot to tell you. That the number I have in mind has no 2 digits the same. And another jump to L230. Now we're at line 680. This is if they got it correct. We print you got it. And the exclamation point is, again, in APL 360 would be composed. Here, it's alt of the minus sign. So we can put that in like that and print a blank line. And then we get, we increment y the number of times that they've won. Y gets y plus 1. If they didn't get it, so line 700 we referenced earlier because we jumped there if they didn't guess correctly. So we're going to ask them if they want to play again. So we do reference that line. We'll need a label for it. L700, play again, Y or N, question mark. We'll get their input. AD gets quote quad. And if it's yes, we're going to jump back up to, this says jump to 150, but we put our logic for, we're going to jump back up to where the computer creates a new number, and that was on line 150. Or, so I'm sorry, line 160 for us. So jump to L160 if AD is equal to Y. Now we're going to check that variable y, which is how many times they've won. If they've won once or more, we'll print that out. If not, we'll jump to 750, which is just the end of the game. So jump to L750 if y is equal to 0. So if at this point they've decided they don't want to play again, but we're going to print a message if they've won, just to give them some kudos for that. So we'll print a blank line and then print a y point bagels buff. Now, in APL 360, we could separate these character arrays from the number array with semicolons, but we have a built-in with this version and using the EX APL extension, the ability to do more complicated forms of number formats. So we're going to need to use that, at least in a simple way here, to include this on that same line. So we're going to print out A, and then the way that we encode where we want digits to be, there's many different encodings for that, and I won't be able to find those. I don't know the page number offhand, but I think it's at the end of chapter 7 where that's explained. Maybe I can get there fairly quickly. So here I am. I believe I'm in chapter 7. I'm going to, yeah, we look at the page numbers at the bottom. I'll move to the end. Okay, so here starting on, it's page 261 of the PDF. We have picture format. And you can use the control functions of numeric characters are as follows. So 0 represents padding zeros outward from the decimal point. 1, float any decorators like minus signs and so on, commas probably, and other things here. I haven't done a lot with these encodings, but a 5 represents a normal digit. So for us, if they've played more than 9 times, then it could possibly be a 2-digit number. So I'm going to put in a 55 here. we'll see how that prints out when we play the game and test this. So A 5 5. So again, that's going to represent the number of times that they've played. Then we have a dash point Bagles buff, and then a couple semicolons, or sorry, a couple exclamation points. And then we print hope you had fun. Bye. Okay, and then we're done with the game. We'll go ahead and close that. We'll go ahead and test the game. Okay, game of bagels, would you like the rules? Let's just test it, make sure that that prints out the rules okay. Okay, so we get the rules. Okay, I have a number in mind. So the computer, we see it, just for testing purposes, the computer has picked 521, and we get our first guess. So let's just say that we don't get, we're not going to get this right. I'll guess 1, 2, 3. So here we have 2 digits that are in the original number, the 2 and the 1. The 2 is in the exact spot. It's in the middle. So we see Fermi printed once for the represents the 2. And the 1 is a correct guess, but it's in the wrong position. So we see Pico being printed for that. So we see Pico Fermi. Now we're on guess number 2. So let's just, again, we'll just guess wrong. And we get up to 5. Now, again, we've short-circuited that so that we have to guess all 20. Then the computer displays my number was 521. Would you like to play again? Okay, let's say no at this point. Okay, so there I have a problem. I left off a label for line 750. Let's see, that was print hope you had fun by. So we need to edit that line. Jump back in. I'm not sure what line number that was. I know it's at the end. So I'll show lines 50 through 60. And it's line 59. Okay, the very last line, I guess. Could have probably guessed that. So we're editing line 59. Looks like, yeah, we are on showing us being able to edit line 59. So we could go into a mode that would let us go back and edit the line with the text already on it and go back to the beginning and insert the label and so on. It's going to be as quick for me to retype the whole thing. So I'll just do L750 : hope you had fun. Bye. Okay, so we get the SI damage because our program halted before finishing with the error. We can clear that. It's fine to run the program again. In testing other programs, if you keep getting error after error after error, eventually you'll get a stack full message, and it wants the SI to be cleared. So we can do that here by just saying right paren SI clear, and then that'll clear that status indicator, and then we'll rerun the program. Okay, no. So again, just make sure that. Okay, so I didn't mean to do that, but I typed in 2 digits, and we got the message try guessing a 3-digit number, and we got to try the guess again. Let me try some other characters here like ABC. Okay, so that did not work. When I typed in ABC, we jumped out of the program and we get a value error. So let's go back and look at our logic for that particular part. Let's see, let's go back into Bagels. Okay, let me display maybe lines 5 through 30. Okay, so that's line 24 here. Um, jump to 300. So the problem is I left out the L. It's trying to jump to a specific APL line number 300, which is after the end of the program. So that means if you're trying to jump after the program, it just means terminate. So we need to rewrite that. Now this is a very long line, so I am going to try to use the mode, if I remember how to do it, where we can see the line and edit it. So we're going to do left bracket, it's line 24. I'll do a quad, and then a 0, I believe, means essentially show the line so that we can edit the code that's already there. Okay, so here we are. I'm going to use my left arrow and go back to the beginning of the line where we have the 300. I'll press the insert key once, go into insert mode, put in an L. Now, I'm not sure if I need to go all the way back to the end of the line or not. I'm not going to take any chances. So I am going to go to the end of the line because I don't want any of these characters left out. Okay, then I'll go ahead and close the program. All right, well, we're getting some more debugging skills here. That's not surprising. Okay, we'll run Bagels again. No rules. Okay, let me try letters again. ASD. What? Okay, what about 1A2? What? Okay, that works now. So let's get through the program. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh well, that's 20 guesses. Do we want to try again? No. Hope you had fun. Bye. Okay, so that works. Let's run the game again. Would we like the rules? Let's say no this time. No. Okay, I have a number in mind, 912. Okay, so this is interesting. We got the same number before. Was it 312? I don't remember. 321 was the computer's guess. I think that seemed to be the same when we ran it. Now we're running it again. The random seed generator has picked the next random number. We didn't reset it, so we get a new number here, 912. So let's guess it correct and see if this logic works. 912. You got it. Play again. Okay. Yes. Now we get 931. So let's just play around with this. We'll do 1, 2, 3. Okay, so we get pico pico. We know 2 digits are not right. Maybe I'll try, or 2 digits are right, but not in the right spot. I'll try 1, 2, 4. Okay, only get 1 pico now. So the digit I left out, the 3, was probably one of the ones that was there. So I'll do 1, 3, 4. Okay, pico and fermi. All right, so I'm pretty confident 1 and 3 are part of the number. Now, if you have 20 guesses, you could easily get to the end and find this. I'll do 139. Pico pico fermi. Okay, and the number is, and I don't remember, was it 931? So we've seen the case where we've got all the guesses wrong. Now let's see. We've guessed a few times. Let's see. I don't know if this is. I don't remember. Okay, it was 931. You got it. Okay, so that works. And after so many guesses, even if you've not used all your guesses and you still get the number right, you get the message. You get it right. Okay, let's say we don't want to play again. We know we've won twice. So let's see if we get that message. Oh, nope, something happened here. A 55-point Bagels buff. So something's wrong with our formatting on that line. Okay, we'll jump back in. It's at the end. So I'll just display 50 to 60. Oh, I didn't finish line 58 where we need to put in the code to show the variable y. Okay, I'll do left bracket 58, quad 0. So there's our code, and then we'll do I don't think we need to do a comma here. The comma is if you want the number to be displayed at the end. So we're going to do the format character and then our variable y. And we'll close that. Okay, we'll run this again. Like the rules? No. Okay, 541. Let's win. Yes, we'll win again. 914. Yes, let's win again. 972. Play again? No. So we should have 3 points to our credit there because we won three times. Okay. At this point, I'm fairly confident that we have our codes working correctly. So let's save. I haven't saved it yet to a workspace. So I can do right paren save bagels. So there it is as a workspace. Let me show you that we can now exit APL, and then we can jump back in and load the workspace from our simulated DOS disk. So I'm going to do exit. Exit, quit. Why am I blanking on how to get out of an APL session? Off. Okay, right paren off. Okay, so now we're back to our disk drive, B drive. I'll do a dir. So you see that we've got those processors here as comms. Here's our APL. You could write a batch file to start up APL with the specific options that you want. And then here we see our workspace. Workspace names can be up to 8 characters long because they're just saved as DOS files here. We still have a lot of space free on this floppy drive. So that's not a problem. So let's run APL again. APL, exapl. Okay, here we are. New workspace will load Bagels. So we're back in Bagels. We could run the game again. I want to go back and edit it and get rid of the sort of the debugging code that we have in there. So we'll go back into Bagels. Now, one of the lines is showing the number. I'm going to get rid of that. Don't remember where that is. So let's look at lines 1 through... I think this displays 23 or 24 lines on one screen at a time. Do 23. Okay, so it's line 18. I want to delete line 18. So the way we delete lines is with the delta character. So I'll do left bracket delta 18. I think that's the right order. And then, okay, now it's on line 19. So let's look at what we have again. 1 through 24. Okay, so line 18 is gone. And it'll, when we jump out and jump back in, it'll renumber these. So that line will be gone. And then we had that line where we set the number of guesses to 5. And that was towards the end. So let me display 40. Oh, let's see. Let's go back to 37 through 60. Make sure we get the line there. Okay, line 41 is where we have that set to 5. So let me edit line 41. And I'll change the 5 to a 20. Okay, let's run the game. Yes, we'll see the rules. Okay, so now I have no idea what the number is. I'll do 1, 2, 3. Okay, Pico, 1 digit's there. 1, 4, 5. Okay, Pico and Fermi, 2 digits are correct. 1, 4, 6. Okay, Pico, Fermi. So 1, 4, 6. One of the digits is in the right spot. 164. Okay, none of the digits are. So it's not the 1. Maybe 641. Okay, that was the number. So seemed like we got lucky on that one. All right, I'm going to go ahead and end here. I'm confident the game seems to be debugged and it's working fine. We can go ahead and save the workspace again. Now I'm going to exit. Okay, so I'm just going to demonstrate this really quick. If you want to save your disk image so that you can load it back into the simulated environment again, we need to do here is switch from the A drive to the B drive. And then we can press the save button. And then it's going to save it to your downloads folder. We'll keep. And it says check our downloads folder for this image. Now I will hit reset. Now I don't know if it's keeping, if I press reset, I think it's just resetting the machine. So I still have my old image here. But if you needed to, you could do load. Make sure you would go back to the B drive here, click choose file, and then go to the downloads folder and find the image or wherever you saved your images at, and then it would attach the image, choose the file, and then press load, and it would load that as your B drive. So any images that you wanted to save, you could have several APL images. If you fill them up, fill one image up with many workspaces, and you want to then create another image with a bunch of other workspaces, you can do that as well. All right, I hope that you found this video as interesting and fun as I had making it, and that you'll come back and watch some of my other APL videos in the future. Thank you for watching.